Research Methods and Statistics. Two authors, Catherine A. Adams, who earned her PhD in General Experimental Psychology from the University of Alabama in the year 1977. She was a Charles A. Dana Professor of Psychology at Guilford College when she retired in 2017 after 37 years of teaching. Her professional interests include gender issues, relationships, interpersonal relationships, that is, and teaching. She worked with the Preparing Future faculty program for 20 years and helped establish the Early College at Guilford, a nationally ranked high school. In her spare time, she spends as much time as possible outdoors, practicing yoga, and bakes chocolate desserts. Eva K. McGuire, also an author of this text, earned her PhD in clinical psychology from Virginia Commonwealth University in 2002. She is a Charles A. Dana Professor of Psychology at Guilford College as well, where she has taught since 2003. Her research interests include environmental psychology and computer-mediated communication. She enjoys walking, yoga, and bike riding, and she loves to listen to live music. Chapter 1, Thinking Like a Researcher. Learning objectives include explaining the connection between thinking critically and thinking like a researcher, describing the scientific approach, including the challenges and benefits of taking a scientific approach, outlining and synthesizing the steps of a research and research process, and identifying and applying ethical principles and standards, as well as formulating a big picture of the nature of science and how science progresses. And imagine yourself lying on your back in the grass. Stare up into the sky, let your mind wander, and let some of the myriad questions you have about the world come. Do not try to answer them. Focus on the kinds of questions that come to mind. If you are like most students in the social and behavioral sciences, many of your questions are about culture, politics, education, history, values, or behavior. And for example, you might wonder how people develop certain attitudes, why people or animals behave in certain ways, and what interventions might help change behaviors or attitudes. And we expect these questions came pretty easily to you because we have found that curiosity is a key characteristic of students who have opted to focus their studies on the social and behavioral sciences. Through your studies, you have begun to develop a knowledge base in your discipline, and perhaps this knowledge inspired some of the questions that you generated. And with some additional thought, you might also be able to apply your knowledge in order to help answer some of those questions. Perhaps you know this, but it is worth pointing out that almost all that knowledge that you have gained through your course was generated through research. And now you find yourself taking a research methods course within your discipline. Perhaps you signed up out of interest, or maybe the course was required or recommended, as this one is. And so you may approach the course with excitement, trepidation, or indifference. But regardless of why you are taking the course or how you feel about it, we bet that this will be one of the most influential that you will take. We would even wager that learning about research methods and statistics will change the way that you think about the world. And we hope you will continue to nurture your curiosity and occasionally stare up into the sky with a sense of wonder. What will change is that you will come to understand or comprehend the process by which we know what we know in the social and behavioral sciences. You will learn to generate more in-depth questions that build on this knowledge, and you will develop the tools in order to systematically investigate those questions that you generate. In other words, you will learn to think like a researcher. A brief note on critical thinking. Critical thinking is essential to all academic pursuits and is therefore an omnipresent term in higher education. We hesitate to use the term here for fear that you have already heard critical thinking defined so many times that the mere mention of it will cause your eyes to glaze. Bear with us because although critical thinking is at the heart of what it means to think like a researcher, it is often misunderstood, even by those who tout its pertinence. One problem is that critical thinking is often equated with criticism. Criticism, of course, can be one of the tools that is used in critical thinking, but simply being critical is not the same as thinking critically. Another problem is that critical thinking is often equated with critical thinking skills. Critical thinking skills are used when thinking critically and are certainly pertinent, but skills alone do not define critical thinking. Moreover, skills are something that you have or gain, while critical thinking is something that you do. Critical thinking is an action that requires dynamic engagement with information or ideas. It involves carefully analyzing that information based on current knowledge, as opposed to relying on personal opinion or beliefs. Additionally, both the knowledge used and the thinking process itself are carefully scrutinized in order to identify and avoid biases. And so thinking critically in any academic pursuit and thinking like a researcher are parallel paths. Where they diverge, however, is that researchers think by doing. That is, researchers think critically as they plan, they carry out, evaluate, and communicate the results of research studies. A note on the scientific approach. Thinking like a researcher first requires one to take a scientific approach. The scientific approach is a scientific type of critical thinking that involves approaching a topic with a genuine desire to understand it, identifying and minimizing biases that interfere with this understanding, avoiding overly simplistic explanations, and following a systematic method to study the topic. That sounds easy, but taking the scientific approach actually requires a lot of risk and willingness to critically evaluate results regardless of our personal beliefs. And so several questions arise when considering the scientific approach. Are we willing to subject our personal beliefs to science? Are we open-minded enough to pay attention to evidence that contradicts our belief systems? And can we truly be unbiased about a subject that we feel passionately about? And what might we lose by taking a scientific approach? Of course, it is much easier to avoid the scientific approach and instead rely solely on personal beliefs and experiences. Of course, it does not take a lot of effort of thought in order to fall back on what an authority figure told you, or to base decisions on a significant event in your life, or to follow the advice of someone you trust. We might even say that these tendencies are our default, and let's face it, people can lead full and happy lives without ever challenging this default. And of course, we see that. Of course, why then would anyone want to take a scientific approach? Of course, not only does the scientific approach necessitate risk, it does not feel good to have our personal beliefs challenged, of course, or to be shown that our beliefs are inaccurate or false. But it also takes more effort, and of course, falling back on a default is very easy. And of course, we think in the book Predictability Irrational, with the subtitle The Hidden Forces That Shape Our Decisions by Early in 2009, he argues that we often make irrational decisions based on these defaults. Moreover, in the book New World, New Mind, with the subtitle Moving Toward Conscious Evolution, Ornstein and Ehrlich in 2000 suggested that our non-scientific default served an evolutionary purpose, but that in today's society, this default way of thinking and making decisions is insufficient for dealing with modern problems. And in fact, they argue that many modern problems are the direct results of relying on our defaults. And so, concerning the scientific approach and decision-making, one reason why we might take a scientific approach is that it can help us better make decisions, both individually as people and as a society, as a species. And so the social sciences were actually formed in order to produce or to perform or improve human welfare and influence social change, although that connection has never been as seamless as originally envisioned. There are many examples of how social science has improved public policy and individual decision-making. Consider the following. The statement, "I saw it with my own eyes," can be quite convincing, yet research shows that such eyewitness testimony can be altered or even slight variations in questioning. In 1998, the U.S. Attorney, then at the time, General Janet Reno, responded to this research and compiled a working group in order to suggest improvements to the criminal justice system. And so the resulting document was the first uniform set of instructions on how to collect accurate and unbiased eyewitness testimony. And that was from the United States Department of Justice in 1999. And so hearing conflicting eyewitness reports might lead us to discount those reports or question the honesty of the witnesses. During World War II, for example, when German officers gave locations of where a ship went down that varied by hundreds of miles, the majority opinion was that the eyewitnesses were lying. However, research suggests that memory decay happens in a somewhat predictable way, and two cognitive psychologists applied this research to develop a statistical profile of the contrasting eyewitness accounts. In the year 2008, the ship was found within 3 nautical miles of the location pinpointed by the psychologists. Although having lots of choices might seem advantageous, research suggests that choice might actually decrease motivation. and deplete self-control. During his presidency, President Obama, for example, applied this research by limiting minor choices, such as what to eat and what to wear, so that he could focus his energy on more pertinent decisions. Many people, of course, believe that an educational intervention is sufficient to change behavior when in actuality it is rarely enough. We can see examples from the COVID-19 crisis when expert advice competed with conspiracy theories and misinformation. And to help align public health strategies with social and behavioral science, a global collaboration of social scientists synthesized and communicated empirical evidence relevant to the pandemic, including how people perceive threats and how best to communicate information. See the APA Science Directorate 2020. And note, in all of these examples, personal beliefs and majority opinion were misleading. Luckily, however, the scientific approach can be used in order to overcome the default way of thinking and to make better decisions. Concerning the scientific approach and knowledge, being able to make an informed decision is a good argument for the scientific approach. However, the scientific approach does not always lead directly to a decision. Still, the scientific approach can be used in order to build our knowledge base, improve our refute theories, and develop new ideas. Take academic honesty as an example. Academic honesty is of particular importance to anyone involved in education. If a professor discovers that a student plagiarized, the consequences can severely impede that student's college career and progress, and it may not matter to the academic system if the student was intentionally dishonest or if the student did not understand or comprehend the rules of plagiarism. In much the same way that those who speed will get a ticket even if they do not notice a posted speed limit sign or know that there is a speed limit. Of course, a professor who discovers plagiarism might take a scientific approach in order to better understand or comprehend the reasons behind academic dishonesty. That professor might dig a little bit deeper, try to discover knowledge and beliefs that students have about plagiarism, in what situations students are more likely or less likely to plagiarize, and what strategies are most effective in preventing it. Of course, in this example, the advantage of using the scientific approach is gaining knowledge. The end result for the student who plagiarized may be the same, and the policy itself will likely not change. However, the professor's knowledge of plagiarism has increased, and so scientific investigation that leads to increased knowledge, improved theories, or the development of new ideas might not have an immediate effect or a novel effect, but it may serve as a foundation for future research that has real-life applications. For example, earlier research on plagiarism has suggested that plagiarism is more common than anyone would like to believe. Because of this initial research, other researchers wanted to find out more about why students might plagiarize, and found that sometimes students plagiarize due to a lack of knowledge and skill as opposed to actually trying to be deceitful. Building on that research, there have been several studies examining educational interventions that are effective in improving students' knowledge and skills. We have an overview of the research process, or as known as the scientific method, first coined by Francis Bacon and René Descartes in the 16th century. Of course, in addition to taking a scientific approach, thinking like a researcher requires intimate knowledge of the actual work of scientists. Those without this knowledge may mistakenly believe that science is equivalent to hard facts, or that the goal of science is to prove something. Of course, these perceptions may be represented and perpetuated by well-intentioned signs, touting that science is real, but of course, science is not about facts or proof, and it does not require belief. Science is about process. The processes of science are traditionally referred to as the scientific method. Others prefer the term scientific practices in order to encompass the full range of activities and the uncertainty inherent in science. Of course, yet method is what makes something a science. Of course, more specifically, science must include a transparent method that can be evaluated and replicated by others, one that can be falsified. Of course, as such, we use the term scientific method while noting some pertinent refinements. First, the goal of the scientific method is not proof, but rather the goal is progress. And if you follow the steps in the scientific method, you can rule some things out or disprove them. And you may also find some answers, but you will most likely generate more questions than answers. And second, the scientific method is not strictly linear, but rather is a cycle. Again, if you complete one step, it may lead to the next, or it may lead you to rethink an earlier step in the process. And of course, Then when it looks like you are finished, the process takes you back to the beginning for you or another researcher to begin again. Of course, to use a physical analogy, when we talk about steps of the scientific method, we are not talking about steps in a staircase that we go up once, never backtracking or revisiting previous steps, but rather the steps are more like the ones that we experience when we are using a stair-stepping machine, such as those found in gyms. But of course, these machines have steps that cycle around, and therefore we are constantly revisiting previous steps, just as we do in the scientific method. In the scientific method, we might even skip a step and come back to it later. And imagine skipping a step on an exercise machine. Of course, third, the scientific method is not isolated, but rather is integrated. The use of the term steps, signals, connection, and the singular method implies a unified whole. Of course, in other words, it is not sufficient to simply memorize individual steps without understanding or computing or comprehending how they work together. Moreover, it is not sufficient to learn only the technicalities of a scientific discipline. Creativity, reading, writing, presenting, collaborating, and management are all essential to science, and they are integrated within the scientific method. And so, you might want to keep these three elements in mind as we outline the steps in the scientific method. The goal is not that you master every concept, but rather for you to develop a basic understanding of the entire research process. We will expound on this process in the rest of the reading. Step 1 is to identify the topic. Your professor may simply assign a research topic, but when you have a chance to choose your own topic, it is worthwhile to spend some time thinking carefully about a good topic. What makes a good topic? Well, first, you want to choose a topic that grabs your interest. Perhaps you read something interesting for a class, or heard a story about an unusual event or a behavior in the news, or have some personal observations that you want to test. Personal experiences and observations are a good starting point for selecting a topic, but be very careful when you choose a topic that interests you. Interest here means something that you are interested in finding out more about, not something that you already have an established belief or opinion about that you are not willing to examine in an unbiased manner. And so, although finding an interesting topic is a good first step, you want to avoid a few of these pitfalls. As a student, you probably have limited time and resources. And so, if you will be responsible for collecting your own data, do not choose a topic that requires participants who you will need special permission to recruit. For example, children, individuals with psychological disorders, etc. Or one that requires equipment that you do not already have. And so if you are doing the research for a class project and the professor is requiring you to use a certain type of research design for the course, such as an experiment, then be sure that your research topic is one that lends itself to that type of design. So you need to think ahead at this point in order to consider data collection and design. However, you do not want to be too specific with your topic, and you don't want to be too general as well. But have some questions that you are interested in examining. That way you can establish a research question, of course, but wait until you read past research in order to develop specific hypotheses or design the specifics of your study. Throughout, we will draw on research from various fields within the social sciences. We will also focus on the topic of academic honesty in order to demonstrate how different research concepts and processes apply within a specific research area. We explain how we choose that research topic. And as college professors, the authors, for example, of this text are keenly aware of and interested in the topic of academic honesty. One situation in particular is one of the author's interests in this topic and helped to narrow the topic from academic honesty to plagiarism. Of course, a student copied several sentences from a textbook without including those sentences in quotations, direct quotations actually, but she did cite the book, of course, but the professor explained to the student that this was plagiarism and asked the student to redo the assignment. The student reacted with anger and was so sure the professor was wrong that she went to the academic dean, essentially turning herself in for an academic honesty violation. Although the action clearly constituted plagiarism, the student did not plagiarize intentionally, and this raises many questions. What do students believe plagiarism is? How do we raise students' awareness of what plagiarism is and help them to avoid it? If a student commits plagiarism, how does that impact our perceptions of the student? And at this point, we have a specific topic, but we are just playing around with different research questions. But in order to further narrow our topic, we must move on to our second step in order to find and read past research on the topic of plagiarism. Step 2 would be to find, read, and evaluate past research. And so let's see here. I went too far ahead. All right, so step 1 was to identify the topic. Step 2 is to find, read, and evaluate past research. And so reading and evaluating past research is one of the most crucial steps in research, and you should do it very early in the process. But keep in mind that you will likely need to keep going back to the research literature while you design, conduct, and write up your study. In other words, this is not a step that you can simply check off and move on. Remember that we told you these steps were not linear, but rather are steps that you may need to revisit. Reading the research literature on your topic is something that you should plan to do throughout the research process. We discuss this more in detail in the next chapter. Step 3 would be to further refine your topic and develop a hypothesis or research question. The topic you started with might be very different from the one that you decide on after you have read past research. And so change is a good thing and suggests that you are truly involved in the process of science. The process of mutability, process after all implies change. Of course, when you have a good handle on what past research has found, you will develop a testable hypothesis that is based on this research. A common definition of a hypothesis is that it is an educated guess. For our purposes, this means that a hypothesis is a prediction based on past research. A testable hypothesis means that it can be disproven or falsified. A belief in true love, angels, or countless other things that cannot be disproven or proven may be very worthwhile on a personal level, but of course such beliefs are not testable and thus not suitable research questions for science. And on the other hand, we could test the idea that having a belief in true love improves the quality of intimate relationships. But a testable hypothesis is an educated prediction that can be disproven. Similarly, as much as we might like the idea that studying research methods will save the world, such a statement is not testable. And as a result, the only way to disprove a statement such as this would be for the world to end. Of course, that is a horrible event on many different levels, and of course it would be impossible to assess exactly what could have prevented it. And with modification, we can make the statement testable, however. Research methods instruction improves decision making. Of course, this is not nearly as exciting as our first statement about research methods saving the world, but it is much more focused and testable. Again, statement that research methods instruction improves decision making. Of course, moreover, it meets our standards for a testable hypothesis because it is a prediction based on past research that demonstrates that decision making can be improved with instruction in critical thinking. Step 4 would be to choose a research design. So we've gone from identifying a topic to finding, reading, and evaluating past research to further refining our topic and developing a testable hypothesis or a research question. Now we move to step 4 in choosing a research design. Design a study that tests your hypothesis, is feasible for you to carry out given your time and your resource constraints, and is ethical. Of course, keep in mind that there is no perfect study, and you cannot examine all the factors that interest you in one study. One of the most basic decisions is the type of research design to use. There are 3 basic types of research designs: descriptive, correlational, and experimental. A single study may have multiple hypotheses that are tested with one or more of these designs. The type of design depends largely on the goal of the research. Just like it sounds, descriptive research simply describes a sample or a population. Correlational and experimental research designs examine relationships among variables, with experimental research testing a causal relationship. There's also something called a quasi-experimental design, in which some but not all of the requirements for an experiment are met. We will go into depth on each of these designs in latter chapters, and of course in the final chapter we will summarize key decision points for choosing a research design. Here, however, we provide some basic information in order that you can begin to familiarize yourself with research design. All designs will have variables that you measure, manipulate, or control. A variable is something that varies in that it has at least 2 possible values. Age is a variable, for example, with several possible values, such as age in years starting with a value of 0 and increasing by values of 1, and so it is quantitative. On the other hand, 29 years is not a variable because it represents just a single value and does not imply any variation. Similarly, the description of having research knowledge does not vary. To make it variable, we would need to discuss it in terms of the degree of research methods knowledge, which might be defined as number of social and natural science courses completed, grade in a research methods course, or score on a research knowledge exam. You will find more information on measurement of variables in the 3rd chapter. And again, just to recapitulate or recap, a variable is a factor in a research study that has 2 or more possible values. Concerning descriptive research examines the who, what, when, where, how, but does not examine the relationships among the who, what, when, where, and how. Descriptive research can be exploratory in nature. It is often used to examine phenomena in more depth or to examine an area of research that is neither new or needs updating. For example, a descriptive study could be used in order to better understand what types of science education, such as natural sciences, social sciences, research methods and instruction, statistics, and so on and so forth, that people find most pertinent. Such a study might examine opinions about how such education should be administered and funded. Moreover, views on science education may change over time, and in that sense, it could be useful to understand attitudinal trends. And we'll see Chapter 5 for more information on descriptive studies. Descriptive research is research design in which the primary goal is to describe the variables, but not to examine relationships among the variables. Then we have what's called experimental research, which examines the relationships between 2 or more variables, and if properly conducted, can demonstrate causation. An experiment goes beyond prediction to an explanation of relationship between 2 variables, and we provide a deeper explanation of how to examine causality in Chapter 10. But for now, you need to remember at its most basic level, an experiment consists of 1 independent variable and 1 dependent variable. And one is IV and the other one is DV. An experiment tests the effect of the independent variable on the dependent variable. An experiment requires that A, the experimenter systematically manipulates the independent variable, B, the experimenter randomly assigns participants to receive different levels of the independent variable, and C, the experimenter measures the effect of the independent variable manipulation on the dependent variable. Alternatively, it could be those who already have good decision-making skills who seek out a research method course. Perhaps there is a third variable that is impacting results, such as an academic major or years of education and experience. And of course, there's actually no direct relationship between research instruction and decision-making skills. Experimental research or experimental design or experiment is that research design that attempts to determine a causal relationship by manipulating one variable, randomly assigning participants or subjects to different levels of that manipulated variable, and measuring the effect of that manipulation on another variable. Independent variable is the variable that is manipulated in an experiment, but the dependent variable is the variable that is measured in an experiment and is expected to vary or change or be mutable based on the independent variable manipulation. For example, the following is a simple experiment in order to determine if research methods instruction increases decision-making skills. We randomly assign participants to one of 2 independent variable levels, taking a 1-hour research methods seminar or a 1-hour driver education seminar. In order to assess our dependent variable after the seminars, we give all the participants scenarios with relevant and irrelevant information and assess their ability to make decisions based only on the relevant information. And in some cases, it is not feasible to conduct an experiment, and a quasi-experimental design might be chosen instead. Quasi-experimental research includes manipulation of an independent variable, but no random assignment to independent variable level. For example, we might compare decision-making skills between students in actual driver education and research methods courses. In this case, participants still experience the independent variable manipulation, research methods versus driver education, but they were not randomly assigned. And like a correlational study, a quasi-experiment cannot demonstrate causation. In our example, participants who are in a driver education course might already be very different from those who are in the research methods course. And we therefore then cannot be sure that any observed differences in decision-making skills were actually caused by the research methods course. Again, quasi-experimental research or quasi-experimental design or quasi-experiment is research design that includes a key characteristic of an experiment, namely manipulation of a variable. However, it does not have all the requirements for an experiment, and that there is no random assignment to the levels of the manipulated variable. And because there is no random assignment, a quasi-experiment cannot demonstrate causation. And so test your understanding of descriptive, correlational, and experimental research designs by completing practice 1.1. We realize that you might be tempted to skip over these practice exercises in the chapters or ignore completely the applications. But we think taking the extra time and extra mile will be worth it, and we base this on research findings that active repetition of material through practice and application is positively correlated and associated with better learning and retention than simply reading and rereading a text. Again, practice 1.1 is to identify different types of research designs. Why would an experiment not be appropriate to investigate the relationship between ethnicity and health? What would be an appropriate research design? 2, the president of a university wants to understand how the beauty of the campus influenced the decision by the incoming student class to enroll in the university. What would be the most appropriate research design? And 3, briefly outline a study in order to examine the impact of social media on mood. What would be the most appropriate research design? Step 5 is to plan and carry out your study. And as you plan your study, you will need to decide exactly how you will measure key study variables and who or what your population of interest is and how you will obtain a sample from that population. If you plan to conduct an experiment, you will need to define or determine how to manipulate your independent variable and test for causality. Before you carry out your study, you will need to get approval to do so. Your professor is the first person who will need to okay your study in order to ensure the study has merit based on past research and theory, that you plan to employ appropriate methods and analyses, and that the study is ethical. Broadly speaking, your study should not harm others and should maintain the dignity and respect of those involved in the study, including those with animals and other humans. If your study involves collecting data from human participants, you will likely need to have your study approved by your college or university's Institutional Review Board, or IRB. The IRB reviews research conducted by both students and faculty in order to ensure that the study has merit and therefore the research is justified. The IRB, Institutional Review Board, also ensures that the study complies with ethical principles and standards, and we will discuss ethics in more depth later in this reading. Again, Institutional Review Board is an established group that evaluates research proposals in order to ensure that ethical standards are being followed in research that involves human participants. Now we will move to step 7, share and communicate results. Research should be a transparent process, and therefore it is important that researchers make their work public. Sharing data and materials promotes verification and replication of results. Communicating what the results mean, how they fit or do not fit with past research, limitations of study, and suggestions for further research allows others to learn from and build upon the research for future novel research. Of course, remember that reviewing past research is essential, and it is an ongoing step in the scientific method, and thus communicating results feeds back into the process of science. As a student, this does not necessarily mean that you have to publish your results in a research journal. That is a possibility, but it is more likely that you will share your results with your professor and your classmates, and perhaps present your study to other students within and outside your college or university. Writing a research report is one of the basic ways to communicate your results to others, and we will go into detail on how to do that. Of course, when you write a report, you have to put the study into context, and you will need to explain your study in your own words. The process of writing and revising the report will help you to figure out how to effectively communicate your study and its results to others. Writing in your own words is very critical to your own learning and to others' understanding of your work. And so no one will be able to understand your study if you cannot explain it clearly, cogently, and concisely to yourself. writing in your own words is also a very important ethical issue. If someone plagiarizes the work of others, then they essentially steal someone's ideas and they hurt the credibility of the entire field. So you may think that you know what plagiarism is and how to avoid it. But plagiarism is more than just passing off someone's entire work as your own. Plagiarism also includes incorrect citation of others' works. You are expected to build on past research, which will require you to summarize and paraphrase the works of others. You should also do so in your own words, and whenever you describe others' works, you need to cite the appropriate source. Test your understanding of plagiarism by completing practice 1.2 in identifying and avoiding plagiarism. And then next, we're going to talk about thinking critically about ethics. We'll talk about ethical codes, ethical principles, and then ethical standards. And we'll start to talk about proof and progress in science in order to finish chapter 1 of research methods, statistics, and application.